ఏటా వాళ్ళు రెండేసేసాయు ఆ
Ma'am, you can start, ma'am. People will be joined. Nothing problem.
Okay.
Okay.
Okay. So good morning, everyone. I hope I'm audible to you all and the screen is visible. So if there's any problem, please let me know in the chats, right? And please turn off all of your audios. Okay, I can still hear people sometimes in the middle. That's fine. Okay, yes. Okay, thank you so much. Okay, so I hope I have met you before and you remember me, hopefully. If not, then let's do it today. Okay. So my name is Priyanka. I hope you know it. I don't know, but yeah, my name is Priyanka, and today we will be carrying on queues. Okay. So you have already done with stacks and everything. Maybe you're good with data structure also. Now you're very good with C programming also. So let's move forward and let's see what are queues. Is that okay? Is everyone with me? Is everyone with me? Yes, no, maybe we are sleeping, we're eating breakfast, tell anything. Only 4 good mornings are there. Yes. All of you, yes? Everyone. So everyone's morning is good today? Okay. Don't message me directly. Okay. Okay, fine. Thank you so much. Okay. Good morning. Okay, so I want this energy or whatever you're replying me. I want this till the end of the session. Till 1:15, I want this energy. Then you can go sleep. I don't mind doing that. Okay. So but till 1 o'clock, you're with me and you will be active. I can say you want to eat something, you eat something, but be active. That's it. Okay. You want to drink coffee, you drink coffee, but be active. Okay. So I know you are doing most of the things in HackerRank, I guess, till now. But in HackerRank, we have lots of programs for arrays and queues, arrays and stacks, as well as linked list too. So you can see here. But if I check queues, we don't have many problems in queues over here. So I'm going for queues, and there are only problems which are medium to hard level. Okay, see, these are the problems. So only medium to hard level problems are there. So initially, I don't want to put a bomb on you by giving all these problems. Okay, queue using 2 stacks and all. Let's do it. If the time permits, let's do it. And there are only these many problems here, if you can see. Okay, so you can have the subdomains here, right? So I've chosen from this and I have got this. Fine. So before we move to the actual problems, let's see what is a queue. Okay, quickly, what is a queue? Answer. Your own answer. Any answer. What is a queue? Yes, and you know what type of answer I want. What's a queue? Quickly. Don't worry, I will not ask you personally. You just message me all together in a group. What is a queue? Linear data structure follows FIFO rule. Very good. 212. Good. Linear data structure. Good. 4M9. 550. 5M8. Yes. 5L8. 259. Abstract data type. Okay. Very good. Good. I want more answers from you. I should know what you know already. Okay. Linear data structure which follows Okay, same linear data structure. Okay, very good, wonderful. See, these many answers, different. I mean, they are same yet different answers. Very good. So, yes, you are absolutely right. It is something called as linear data structure, and it follows something called as FIFO, right? Okay, so first in, first out, right? Normally, if you see, I mean, you are, I think, in third year probably right now. So anywhere we study, normally anywhere you study data structure, everyone will be, behind stacks and queues mostly. Okay, we have to learn stacks and queues, and there will be something. There's no new subject in it. Okay, there is nothing like today I will give you a new question on queues, very interesting question. No, I cannot give you that because queue is queue. I cannot, make it something different and give you any other question. But why do we emphasize on cues? What is it like? Just for your what do you say? If I give you a question, insert an element in the queue. That's it. So only for that we are going to learn cues, insertion from this one and deletion from something. That's a common question, right? But why do we ask that? Is it important? Is cues or are cues used in real life, or are cues used if you go for a company? Is it used over there, or it is simply for any of the company's specific purposes or just to pass your exam? So how is it? Can you tell me? Is cues used in real life or not? And if yes, where can we use it? Give me some examples where. Very good. 259 call centers. Good. Okay. Oh, yes. Okay. Where now? Let's see where. Ticket counters, very good. Movie theaters, good, good. Ticket counters, okay, okay. Other examples, other examples. Okay, railway stations, good. Movie theater. Now give me an example like how engineers see. Where do we use it? Yes. Railway station, good. More examples, more. A one-way road, good, good. Nihita said biscuit packets. Wonderful. See, that's the kind of example engineer thinks, right? Very good, Nihita. Biscuit packets. What about others? Yes, girls. The chat has stopped in biscuit packet. Okay. More answers. Bangles. Very good. Bangles. Good, good. Okay, so you have told me a lot many answers, literally lot many answers. So, bangles. I don't understand bangles. How bangles? Okay, okay. Books. Very good bunch of books. Okay, there are different things. Now see that order. If I just wear bangles, I have to take it in an opposite order. It's last in, first out, right? So depending on different positions you're telling. Grocery store, very good. Execution. There somebody comes. 5M8 while executing threads in OS. Very good. So, okay, enough. Now we will actually discuss like where do we use it. Very good. There are some answers which I got. Absolutely right. See, all these are very, very right answers. Maybe railway stations, maybe a queue in a bank, right? So the queue is basically who goes first will get served first. You can also you can tell it as first in, first out. Okay, but can you also tell it as first come, first serve? Can we call first in, first out as first come, first serve? That is FCFS, if you have heard it before. Yes, yes, okay, very good. So what does it mean? So whoever is in the first position, okay, has to be served first, right? That is the meaning of that. Now in the bank also, you go into the bank, you'll be, if you're in the first person in the line, then you'll be served first, right? So as an engineer, you should know that queue plays a very, very important role after arrays. Okay, after is everywhere. Now, for example, you are going into a field of, say, where Unix is used, okay, and many fields like, if you go for any fields like automation, or you go to artificial intelligence and all these fields, if you work, see, you'll not get a work only in software fields, right? And if you get in software fields, obviously Linux is one of the important part there. So mostly when you program in such things, okay, I'm not telling this as a normal person, okay, movie theater, no, okay, that is all as a real-time example you're giving me. But as a programmer or as a person who is working for a company, in the future you will be able to work with queues, arrays, and so on. Okay, where they will ask you to, simply, for example, you are building a transmitter, okay, or you are building a just take a black box, you're building a box whereby you have to enter messages, okay, and then store it for some time, and then you have to give it out for the receiver. Understood? So you have to enter the messages, that is, you have to receive the messages, and you have to forward it to somewhere. Okay, this is your work. Now, when you receive the messages, can you do it in a last in first out manner? When you receive message, suppose the message is hi, this is Priyanka. Okay, if the message is hi, this is Priyanka, can you give in last in first out manner? So it is, the message is hi, this is Priyanka. Okay, so this is the message. So if I take it in last in first out manner, so what will be taken first? So first hi will be taken, so it will be taken as H, then I, then there is a space, then I will get T, and this side I'll get H, and this side I'll get I, and this side I'll get this, and again space, and again, if I'm wrong, please correct me out. So I, and this side S, and this side again we have P, R, I, Y, A, N, K, A. Okay, now this is the message which is being stored. Okay, this is not being stored. If I take this as last in first out, this is how you're gonna get the message. Am I right? Correct? If I store this as character by character. So in this case, or in any case, can we use stack instead of queues? Can we use stack instead of queues anywhere? Is it possible? Yes or no? Yes or no? Your answers. Reverse a string. No, see, don't only consider your, academic problems. Okay, please write a C program to write this, C program to write that. No, I'm talking about a higher level problems where you have to receive a message and send it to the receiver. So in this case, can you use stack? Yes? No, we cannot use stack. Why? Because it reverses the message, right? Correct. So I don't want that. I want the first, if see, message number 1 comes, message number 1 only should be right at the other side. So at that case, which comes into picture, you have to take Q as your savior. Understood? So only Q will help you in that case. Okay, so this is some of the real-time example of why Q is used. Okay, so basically when you have to transmit a message from one receiver end to sender end and so on. Understood? So these are also, queues are also used in other parts, as you told me. Of course, maybe ticket counter. Again, the software uses queue there. Why? How? Let me see. If ticket number 1 is gone, next it will check for ticket number 2 and so on. Right? So basically, you're just giving the tickets in a first out manner. Am I clear to you all? Okay. So that's about queue. Now coming for so I can tell this queue as a data structure. Okay, this is a data structure because you are structuring the data. You are trying to store a data in such a way that your access is easier, right? So it can be considered similar to queue of that of real world. So whatever comes first will go out first. This is the main summary of that. Okay. Now coming to this, okay, now this is like a hollow pipe. A queue is like a hollow pipe. Now there are 2 ends for that pipe, right? What are the 2 ends for that pipe? One is the end where we enter the data, other end is where we receive the data, right? So can you tell me what are those 2 ends quickly? What are the 2 ends? Yes, very good, very good. What about others? What are the 2 ends? Okay. Okay. Front end, rear. Okay. So look at this. These are two most important. I can say not advantages, the application of cube. Okay, and you are right. There's a front end and there is one of the rear end. Okay, we will discuss about that. Okay. So coming to this queues, okay, where is it applicable? So when a resource is shared among multiple customers or consumers, okay. So the best example, if you have learned data structures, have you learned data structure before? Yes or no? Or are you learning in this semester or something like that? Have you learned data structures or yes or no? At least computer science students, yeah. Okay, yes, completed, finished. Okay. Other section or other branch students are also there, right? Yes, or did everyone study? Okay, you're learning, you're studying now. Fine. So I'll consider that some of you have some idea and some of you have studied data structures, right? So when a resource is shared among multiple consumers, so can you give me an example for this? A resource that is shared among multiple consumers. Yes, anyone? A resource is shared among multiple consumers. Printer, okay, that's a good thing. Servers, okay. No, a problematic example, what you have studied in your DS, that is data structures. Remember? So, do you remember a problem called as dining philosopher's problem? Do you remember something called as dining philosopher's problem? Yes, now the flash, suddenly, right? Yes, chopsticks, remember? Okay, very good. Okay, one was that, and one other was someone. What was the other problem we had, which you have studied, if you remember? Yes, very good. Producer consumer problem, right? Producer consumer, very good. So these two problems are very good classic examples of how memory is being shared between multiple consumers. Producer consumer problem was one process produces and the other process consumes, but the other part was your dining philosopher's problem. And this classic dining philosopher's problem, that was those who don't know, it's simple problem where you have spaghetti, you have to eat spaghetti, and you have chopsticks for that, and chopsticks are shared between people. So you have to schedule on how one person gets a chopstick when the other person is sitting idle. Okay, so that nobody starves and dies. That's it. Yes, Banker's algorithm is also there, right? So now, if you consider this dining philosopher's problem, when if you move forward in your life, also you go for a job and all, still you have to deal with this problem. Trust me. Okay, this problem has different variants. Okay, different types of problems are there. So based on this problem, we can build number of problems, and you'll have to solve that in one or the other context. Okay, so this is one classic example, and which will include what? CPU scheduling and disk scheduling. You know that. What is CPU scheduling? To schedule something, to schedule anything. For example, I'm scheduling my day. So for that, I should know, okay, if this much time I'm going to spend, I have to start. See, I'll not start from night. I'm going to start from morning, okay? So morning from 8 to 9, I will do this. Again, from 9 to 10, I'm going to do this, right? So that is scheduling, okay? Same way for CPU, when you are scheduling, that which resource has to be taken care of. Suppose, now CPU will be taking care of a printer. Now, this this printer is being allocated only for our, say, WordPad, or the printer is only allocated for this computer, or the printer is allocated for the other computer. So all these things include CPU scheduling. Okay, I hope you know, if you have studied operating systems, CPU scheduling is very much familiar to you all. So we have different algorithms. What are the different CPU algorithms? Iman? Quickly. Yes, we have FCFS, very good. We have shortest job first, we have round robin, very good, correct? So we have lot many algorithms, and that is my point. All of this uses stack or queue? All of these algorithms, yes, very good. Priority, yes. All of these uses either stack or queue. Which one? Queue, very good. All of these uses only queue and not stack, remember. Okay, so where is this queue used? In when you go for detail, when you go for application, because you should know this. Okay, because in real-time questions they will not give you a question like this. Okay, now build a queue and insert these many elements and remove these many elements. No, this will not be the question. The question will be there is a computer, okay, which needs to be scheduled somehow. Okay, and please help schedule them. This will be the question. How will you schedule them? What will you use? That is on you. Okay, and that is why I have told you this. Whenever such scheduling question comes, or it's a questions like there is a computer which is idle for this time, and now you have to assign some work and all these things, you have to definitely use queue. Okay, how and all we'll see now. Next, when the data is transferred asynchronously, okay, data not necessarily received at same rate as sent between two processes. That is, see, when I send a data, the same rate, if I send, say, 3 messages per millisecond, okay, 3 messages per millisecond, when it receives, it can be just 2 messages per millisecond. When there is asynchronous data, which is not related to time, okay, then also your queue is important, because queue can save multiple data. Am I clear with the applications, everyone? Am I clear with applications? So if such type of question comes, can you understand that we have to use queue only and not arrays or something else? Yes, okay, fine. Okay, good. Okay, then, so that we have seen how to, we have a rear end and we have a front end and all these things. So what are the types of queues? Anyone? Types, different types of queues. What are the different types we have? We have, okay, NQ, okay. Yes. Circular, double-ended, circular, okay. So very first is, as we studied, is your simple queue. Okay, very first is your simple queue. So simple queue is, as you tell, simple. That's nothing. Only one end, one rear end, one front end. That's it, and the operation will go on. Okay. And the second one you speak about is circular queue. Understood? Circular queue. I will tell you what are all these, and you also know that I need not go in depth for this. Next, you have. I cannot say this is a type of queue, but we consider this into types only. So this is priority queue. Okay, priority queue, and your lastly will be double-ended queue. Okay, so these are the types of queue, 4 types of queues. Again, will they ask a question if anywhere you're writing a test or anything? Will they ask you a question like this? Okay, so we have a circular queue, we have a priority queue, so you enter the elements and delete the element. Will the question will be like this? No, the question won't be this way. Always remember, question will be related to its applications in data structures. Understood? Suppose we have a question on structures. Okay, structures and unions. How it will be? There is a student. He has an ID. He has a name. He has something. All these things it will be given. Now try to do something with that. Now you suddenly know. Okay, he has ID. He has name. Everything is in different data structure. So I'm going to use structures for that. Right? Same way here also, how to decide whether you're supposed to use simple queue or circular queue or priority queue or double-ended queue. How do we do that? Depending on application, how the question is framed, depending on that. Understood? Okay. Now, what is a simple queue? What do you mean by simple queue? Yes. Somebody asks you, what is a simple queue? What would you answer? Linear. Okay, linear. Good. If it's not circular, it's linear. Okay. Good, good. Others? Anything? Okay. So let me just show you. Why not? Let's show you. Like, okay, that's fine. So I have deletion end? Yes, it's a normal queue in which insertion happens at one end and deletion at other end. Okay, and remember this, guys. Insertion can happen in any end and deletion also can happen in any end, basically. Okay, it need not be insertion from front and deletion at from rear, or insertion from rear or deletion from, it can be anything. Okay, but make sure your entire program follows the same whatever you have used there. Okay, so normally when somebody teaches you, they'll consider one. Okay, insertion happens at front, deletion happens at rear, or insertion happens at rear, deletion happens at front. Okay, it's right, absolutely right, but it needn't be like that. Remember that. Okay, but when you follow something, if you follow, okay, insertion will be at front end and deletion will be at rear end or something like this, then you have to follow the same thing everywhere. Okay. Fine. Now coming to the simple queue. So again, it has one front end, one rear end, insertion, deletion, that's it. So in circular queue, what happens? In circular queue, the first node, okay, I can call it as node, the first node is connected to last. Am I right? Or I can say last node is connected to first. Understood? So that's the circular queue when it forms like a circle. Okay. Coming to priority queue. Can you tell me what is a priority queue? Yes? Priority queue. Someone. What is a priority queue? Yes, very good. 419, 210, wonderful, wonderful. 522, 4M9, good, good. What about others? Yes, 5E2, good. I want answers. What is priority queue? According to the priority, the elements will be inserted, or not only inserted, every operation will become based on the priority. Understood? So the priority queue is nothing but it's, you can call it as a special type of queue. Okay, in which element. Okay, so here I have each element is associated with the priority. Okay, I'll say I have the elements as 1, 2, 3. So my priority is for 1, my other priority is for 2, and so on. Okay, so they're served according to their priorities. Maybe any operation, maybe insertion, maybe deletion, maybe traversing or anything, but we perform operations based on priority. Very good. 5A0. Good. Okay. Next we come is double-ended queue. So what do you mean by double-ended queue? Now, you know this. Please tell me. What is double-ended queue? Yes, both the ends. This is important. See, both the ends are used for both deletion and insertion. Understood? So both the ends are used for operations, you can say. Okay, both the ends can be used for insertion and deletion. Good. Now, what is the difference when I said initially I have told a statement? What was that? Insertion will be from one end and deletion in simple queue, but it can be any end. I can insert from any end. See, what I meant was, if you're taking a simple queue, okay, if you're taking a simple queue, then what you can do, if you're taking a simple queue, you can make insertion maybe from rear end, okay, and deletion from front end. Okay, this is the way how it works, if it works like this. Okay, if you're taking a simple queue. Now you can't change this throughout your program. Remember, you have to follow the same throughout the program. Okay, if I can also do this as I can take insertion at front end and deletion at rear end. Okay, they are just variables, that doesn't matter for us. Understood? But follow the same throughout the program. Understood? But when it comes to double-ended queue, anything you can use. You can change, insert or delete through any end. I mean, both the ends work through there. Understood? There only one end, whichever you consider, that end should be there. But here, any end. Throughout the program, you can use anything out of this. Am I clear? The difference? Yes or no? Okay. Any doubts you have till here? Till here, is there any doubt? So I'll ask you a question if you don't have a doubt. Quickly. I mean, this question needs some thinking. Okay, that's it. So, what question can I ask? Yeah. What is the advantage, or is there any advantage of using circular queue over simple queue? And let us discuss. Do we have any advantages or do we have any disadvantages on that? Using circular queue instead of simple queue. Advantages, anyone? Or any limitations or disadvantages? Let's just discuss. Very good. Geetika says memory is saved. Yes. Overnight. Yes. Memory. Good. Yes. Reduces memory wastage. Very good. How can somebody tell me how memory is saved? Anyone? Okay. I'm showing you a picture here. Good. So here you all say memory is saved. Now, how is memory saved? Last one is connected to the first one. Now, if you see here, okay, this is the queue we have. Okay. Now, I will enter at this position. So, I have just a minute. Okay. So, I'm going to insert at this end. So suppose I'm going to insert at this particular end. Okay. So what end is this? This is maybe okay. It's called as rear end. Okay. So if I enter from this side and I keep on adding elements and I reach this end, correct? I'll reach this end and that is my front end now. Now, in case of simple queue, what happens? I can, if ever this is full, if the last one is full, but the first one is empty. Okay, I cannot enter anything in the first one. I have to enter it at the, either I cannot enter or I have to enter it at the last one. But in the case of circular queue, if this is full, I simply get connected to the last one. I'm so sorry for this drawing. I hope no artist gets offended by this. But did you understand? It just goes and that is like a circle. You can continue this. So there is no memory wastage. Very good. So somebody answered, okay, once the element is deleted, that space will be allocated new element once queue reaches last point. Very good, Pratyusha. Good, good. Okay, so most of you have answered. Usha, Shri, Swati, good. Okay, so that's how your queue works. Okay, circular queue, that's one of the good advantage. Okay, that's memory wastage. Okay. So one more, let's talk about one more thing. Priority queue. Used anywhere? Can you tell me some of the examples where priority queue is used? Yes. So does first come first serve use priority queue? No, where? I want real examples. Like, you have studied some of the algorithms. Okay, round robin. Round robin priority queue? Sure. Yes. Okay, scan and see scan. Okay. Binary tree. Very good. 259. Good, good. Okay. Okay, let me just remind you some of the algorithms that you have studied. Okay, so I think you have studied, I don't know what you call Dijkstra's algorithm. Dijkstra's. Yes, I don't know what you call Dijkstra's. I don't know. Yes, some of you yes, some of you no. I don't know how. Okay, I'll tell you. That is an algorithm which is used to find the shortest path. Okay, like see, you have a map, Google Map. Google Map only shows you the shortest path or the distance which takes very less time. So it's kind of similar algorithm. You have Prim's algorithm, if you remember, Kruskal's Prim's, right? So, and this is mainly, priority queues are mainly used based on, for the artificial intelligence too. Okay, by artificial intelligence, you are building a robot. You should know, what is your priority. Now, if there is a lady coming, okay, there's a lady coming, you're driving a car, that is a driverless car, okay, very sophisticated. There's a lady coming in front of you, okay, and what else? There is a, okay, there's a lady coming in front of you and there is a footpath nearby. So what should be your priority, saving the lady or saving the footpath? Obviously saving the lady, right? So that's that. I just gave an example. So there is how your artificial intelligence uses priority and also heap sort. Okay. Now coming to your operating systems, we have different algorithms together used. We cannot say only priority is used. So if you know, I mean, there are a lot many. Okay, rate monotonic. Yes, very good. Who is that? 4M9 interrupt handling. Good, good. Okay, so interrupts also have different priorities. Okay, so that also multi-threading, good. So all this uses priority algorithm. You can just check, okay, where which algorithm uses priority queues. Okay, so you have various sorting algorithms that also uses priority queues. And why am I telling this again? Questions. Okay, the questions which you get, scenario based questions, what you get will not mention the word priority queue. They will say something like, you know, sort this using something. Okay, the priority is higher for this. You have to understand them. Okay, you have to use priority queue. Okay, coming for double-ended queue, not much we use double-ended queue. Okay, anyone who knows the application of double-ended queue? Anyone who knows the application of double-ended queue? Yes, anyone? Double-ended queue. Where is it used? Where do you think? A small. Everyone knows that actually. A double-ended queue is also called as DQ. Okay. Yeah. So where is it used? Bangles in a stand. Okay. Oh, someone gave me the answer. 4M9. Very good. 4M9 gave me the answer. Good. 5M8. Okay. Very good. Okay. So she 4M9 told internet browser history. Wonderful example. Okay. Internet browser history. Meaning, suppose I have just typed, you know, say www.facebook.com. Okay. That's how I put the URL. Okay, I went next and I suddenly press the back button. So when when I press the back button, I come to the previous whatever page I was there. Correct? So these things are also using what? Double-ended queue. And vanishing previous messages. Yes, very good. And one more thing is undo operations. Very good. 4M9 undo operations. Good, good. Okay. So that is also used. Undo, you know, Control Z, right? So there also a DQ mechanism or double-ended queue mechanism is used. Now, if you see, okay, when you see double-ended queue, you're very sure now that your double-ended queue or this DQ can also, oh sorry, DQ. Okay. DQ is used as what? It can be used both as stack and queue. Remember, why? Because you can delete in one end and see, suppose I enter through one end and I remove it from the same. Understood? So that is why it can be used as stack as well as queue. Yes, correct. Usha Shri, right, correct. It uses stack. Undo uses stack. Okay, but DQ acts both as stack and queue. Understanding? Suppose there is a DQ, there is a double-ended queue. I will enter through one end and I will delete from the same end. Understanding? Because I can delete and enter from any end. So I will enter through one end and I'll delete through same end. So now what am I using? I'm using the same double-ended queue as a stack. Clear? Now if I enter through one end and delete through other end, then I am making it to act like a queue. Understanding? So you can say it the DQ data structure supports what your stack as well as queue, or you can say in clockwise and anti-clockwise rotations. Understood, everyone? Okay. So is there any doubt till here? Any doubt till here? Yes, please let me know if there is any doubt. Did you understand? Did you understand or not? Let me know quickly. Yes. Clear, 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 clear. Okay. You say you're clear, I don't know. Okay, fine, fine. Fine then. So it's clear. Simple queue applications. Okay, simple queue applications is used in anywhere. Like for example, in history we can't insert in both the ends. No. See, listen here. Now, when I talked about internet history, okay, what happened there? I will. Okay, I'll show you this. I'll show you through internet itself. Now, this is my browser. 1 minute. Okay, this is my browser. Now I will just I'm just going to some site. Okay, so I'll say www dot maybe google.com. Simple. Okay, google.com. So I press enter and I'm going to this particular field. Okay, now if I just search here something, okay, okay, something, I've searched something. Now I will go back. Okay, I am going to my previous URL. Okay, and I'm not going to my home page directly. I'm going to my previous URL. Now from here, if I say I have gone to some website, suppose I've gone to some website, or see, I'm searching for online C compiler. Okay, now I'll go to this particular website, suppose. Now, if I go back, I'm going to the previous website. If I go back, I'm going to the other previous website, and then I go back, I go to the new website, right? Now, if I go front, this option is also there. Don't forget, we're not just coming back, we are also doing redo. If this is our undo button, this is our redo button. Understanding? So that is when I said that DQ will both act as a stack as well as queue. That means I can move forward and I can come backwards too. Which is this possible? It is possible in queue. Understood? Now stack is what? Mainly undo. Going back to the previous step is stack. But going back and going front is the step of queue. Okay, so what I meant was that, so whenever you use DQ, you can work as it as a stack or a queue, depending on the operation. Okay, there was one more question. Simple queue application. Yeah. So what is the application of a simple queue? Anyone? What did I say? Application of simple queue. Where is it used? You told me many. Yeah, threads and operating system and all. Any other thing? Any special operation or application? Yes, it's a most basic queue. Okay, so it's a most basic queue, like booking tickets and all. So I can say the applications are mainly in scheduling, okay, or memory management, and especially you told me a very good example, call center, right? How the call center works, they'll receive your calls, they will tell, okay, we'll connect you to the other person, and they'll connect it and so on. And that's the best example. Where you come, yes, breadth first search. It depends on what queue you're going to use in breadth first search. Okay, need not be only simple queue, but yeah, that's a good example. And of course, your scheduling, and very good example, interrupt handling too. Okay, so remember, you cannot say only one type of queue is used for this. Okay, for example, yeah, CPU scheduling. Okay, now if you're scheduling CPU in simple fashion, like first come first serve, then simple queue is okay. Now, if the CPU scheduling is happening in something like rate monotonic algorithm, or it is using some bigger algorithm, okay, or you say round robin. So what happens in round robin? You have to go after a certain quantum, you have to go back and you have to do the remaining task, right? So that depending on the example or depending on what algorithm you're using, your queue will be decided. Okay, video fast forward or backward. Yes, back. Okay, yes, I am not sure about that much, but yes, that's a good example. That's a good real-time example though. Okay, okay then. So I hope this is clear to you, all the examples and applications, questions. Any other questions you have? Please ask now itself. Yeah, video forward will be DQ only. I mean, the algorithm is right, but I'm not sure whether queues are used in this. Okay, algorithm is right. Of course, it works in that way only. Okay. Oh, any other question you have? Girls, you there still? Or have you slept? Still there or slept? Did you understand? Please respond. Yes, we are alive. Something like that. Are you girls there? Yes. Yes, I want answers. Quick, quick, quick. Don't raise hands. Tell me yes or no. I want to see. Okay. Yes, yes, yes. Good. Good. Okay. So please let me know if I'm fast or is this okay. Okay. Are you feeling that I'm fast or very slow? Please let me know. If you're feeling sleepy, go wash your face and come and go. I'm not going to stop here. Okay, fine. Okay, okay, fine then. Okay, thank you for your response. Okay, now we come to our your favorite part, that is our programming, right? So, are you doing this on laptops or not? Girls, laptops, computers, or anything? Are you doing programming or not? There, or simply sitting and listening to my bhajans? Yes, sure. Okay, doing. Not on pen paper, only on laptops. You have to do it. If you want me to go slow, I'll go slow also, but I want you to do it slowly, but I want you to get the outputs. Okay. Doing, okay. Okay, fine. So let's see. Now, okay, there we go. Okay. So, coming to the arrays. No, not arrays, sorry, in queues. Okay. So, how do you suppose I'm asking you to schedule something. Okay, I'm trying to schedule some algorithm. Okay, I'm asking you to run an algorithm. So how do you do that? Now, there is no data type called as queue. There is no data type called as stacks or something. So how do you do it? How do you implement queue? Now, I'll say, please write a program to illustrate the algorithm round robin. So how would you do it? Yes? How do you do it? Using arrays and linked list. Very good. 4M9. What's your name? 4M9. Name. Your Peru. Alekhya. Okay. Good. Very good, Alekhya. So, coming to the point, yes, Alekhya is absolutely right. We are doing this using arrays or linked list. Okay. Remember, queues or stacks, we don't have a particular data type in C for that. Okay, so I cannot say simply like, if I say queue A, this is not right. Understood? We do not have any data type for that. So we have to implement the working of queue either using arrays or linked list, depending on the problem. Okay. Suppose I have to use Yes, very good. It's an abstract data type. So this is an actual word for that. Abstract data type. That means it doesn't have a primitive data type, or you cannot just declare just like that. Okay. Yes. So going to the, okay, there's one more point I want to tell you. What is the difference between stack and queue? Okay, I mean, where does it differ? Can somebody tell me where does, now don't tell one is first in first out, one is last in first out. I know that. Okay, now at which point stack is different from queue? Yes, very good. 2 not 6. Very good. At the output, or I can say not only output, at the removal, or say deletion, or output, or whatever you can tell me. Okay, insertion does not differ. I mean, it will not change. Insertion will not change mostly because see, you just keep on inserting. What changes? Removing. Understanding? Okay. So removing will change. Whereas in stacks we remove from the same end, but in queue we remove from the other end. Understood? Okay, clear? I mean, you're telling the same thing in a different ways. Yeah, priority. See, we are talking about normal, simple queues. That priority and other types of queues. Okay, priority again. Insertion doesn't differ. We are inserting the elements based on priority, but we are not using some other method for insertion. Insertion is just putting out the elements, but priority we know. Queue doesn't know the priority. Understood? Okay, so that's the one point. The deletion. Okay. Okay. Now, when you use arrays, okay, when you use arrays, there are two parts you can use. Either you can use array something like this. Okay, you have int ARR of some max element. Okay, this is the point, and you perform all the operations based on this. Okay, this is one of the thing. But is this efficient? Is this efficient? I can show you a program, I guess. 1 minute. No, ma'am, not efficient. Can you tell me what are the other efficient type? Oh God, okay. What is the other efficient type? Okay. Look at this program. Okay, we have int array, and see, we are taking some, it's simple. Okay, there is an array. We are trying to make changes in that array only. So this is not efficient. Why? Can you tell me some of the reasons why this type of program is not visible? I mean, it's not efficient. No, I mean array only. Don't go to linked list. Yes, very good. Ushashri, sorry. Size of array is not dynamic. Very good. See, our number of elements may change at any point. Okay, and what is our basic thing? We have to write a program. See, I can show you this program. It's easy. It's very damn easy. I can tell you. It is just incrementing, and we are just checking, and so on. We are done. Okay, but it's not efficient. If I even tell you this, I have to tell you the other way also. Okay, so instead of learning such program, why don't we learn the programs which we have in pointers? Yes, very good. In array, when we want, we insert an element. In between, we need to remove the remaining elements, which is difficult. Yes, right. But main problem is the size. Understood? And in array, when we, yes, as we remove the elements, there will be a memory gap. So that is when we come for our pointers and dynamic memory allocations. Okay. So question, same question. Is pointers difficult or easy? Is pointers difficult or easy? Yes? Difficult to implement? No. What are you talking, Ushashri? Easy. 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 Okay. Others? What about others? Only for 513 it's easy. 5F9, easy. Okay. Others, answer me. Pointers. Easy or tough? Don't message me personally. If you want to give me your WhatsApp number, you message me later. Here, don't message personally to me. Difficult. Priyanka, your name should say it is not difficult. A bit difficult. Okay. Others say easy. Most difficult. 259. Most difficult. Superlative degree. Okay. So for some people it's easy, for some people difficult. If did I teach you pointers at any moment, any point? Did I teach you pointers? Yes, and still you say it's difficult. Now I'll come there and hit you, monkey fellows. Okay, so it's not difficult, it's easy. Okay, now let's see how it is done. Okay, so when we come to cues, I'll directly do it in this. You want white screen or black screen, which is easy to see? White. No choice. Oh. Majority black. Okay, fine. Let's continue with black. Not for sleeping. You have to see this. Okay. Okay. So let's do it. So how do we write a Q? Okay. First thing to know is Q has two. What are the different things for Q? I'll write it here. Yeah. So our Q has different parts. What is this? Tell me. One is our front end, right? Next one is our rear end. What are the different parts I'm asking? Okay. What else? What else do you have? Yes. Same as array. What is it has? It has a size. How many elements are there in the queue? Size is required, right? And lastly, it should have a capacity. Yes or no? See, capacity is different and size is different. I have told you. See, suppose I buy a bucket. Okay. When I buy a bucket, I will not buy a bucket for, see, suppose today I want 2 liters of water. So I went and bought a 2-liter bucket. Tomorrow I want 3 liters of water. So I go and buy a 3-liter bucket. No, right? I won't do that way. So what I buy a 20-liter bucket. Suppose I buy a 20-liter bucket. Today I can fill 5 liters. Tomorrow if I want, I can fill 10 liters or whatever. So the 20 liter is the capacity of the bucket, whereas the size is, if today I fill 5 liters, that is my size today. If tomorrow I fill 10 liters, then that is the size of the bucket. Understood? So suppose I fill 10 liters today. So what is the capacity of the bucket? 20 liter. But what is the size of the bucket? 10 liter. Am I clear, everyone? The difference between size and capacity. Size is how much is there inside the bucket. Whereas capacity is what is the total capacity, how much it can handle. Okay. So can I say these are the parts? Right now I have told everything, but Q should be implemented using a array in our case. Understanding? These are the elements of my Q here. So I want a rear end. That is the thing, but just a variable which says front, variable which says rear, and there's a size, there's a capacity, there's an array. Okay. So same thing. Now, which data structure should I use for? Which data type should I use for this? Tell me. If I want to take the different types and take it as Q, then what should I use? Very good. I should use structure. Understood? I have to use structure. So let's use it in our program. Okay, here it is. So let's remove this main and all. Okay. So I'll write struct. 1 minute. I'll increase the font for you. Is it visible, everyone? Later on, don't say I couldn't see anything, ma'am. So I did not understand anything. Visible? Okay, yes. So struct. Okay, this is how you use struct.